Ever wondered how fast an aircraft can fly? Let's embark on a journey into the world of supersonic flight. In the early days of aviation, the sky was the limit. Literally, human ambition soared on wings of fabric and wood, reaching for the heavens. But there was an invisible wall that seemed unbreakable, the sound barrier. Breaking it was more than just a race for speed. It was a test of human ingenuity, a challenge to push the boundaries of what was possible. The sound barrier, or Mach 1, is the speed of sound, approximately 768 miles per hour at sea level. At this speed, air molecules can't move out of the way fast enough, creating a wall of air pressure, the infamous sonic boom. This posed significant technological and engineering challenges. Early aircraft attempting to break the barrier often met with catastrophic failure, their structures unable to withstand the immense pressure. But engineers and pilots were not deterred. They knew that to overcome this barrier, they would need a radical change in aircraft design, materials, and engine technology. And so, they went to work. One of the most significant milestones in this quest was the Bell X-1. This rocket-powered aircraft, with its bullet-shaped fuselage and thin, straight wings, was a marked departure from conventional aircraft design. It was piloted by none other than Chuck Yeager, an Air Force test pilot with nerves of steel. On October 14, 1947, Yeager did the impossible. He broke the sound barrier, reaching a speed of Mach 1.06, marking a new era in aviation. The X-1's accomplishment was a testament to human tenacity and innovation. It proved that with the right technology and a daring spirit, even the sky wasn't the limit. But this was just the tip of the iceberg. The sound barrier was broken, but the thirst for speed didn't end there. It was just the beginning. In the midst of the Cold War, a need for speed and surveillance birthed an engineering marvel. The Lockheed SR-71 Blackbird, a high-speed, high-altitude strategic reconnaissance aircraft, was designed to outpace and outclimb any threat. Let's delve into this extraordinary chapter of aviation history. The SR-71 Blackbird project was born out of necessity. The 1960s was a tense era, marked by the escalating conflict between the United States and the Soviet Union. In this climate of uncertainty, the US needed a way to keep an eye on potential threats, and that's where the Blackbird comes in. The task of designing this advanced aircraft fell on the shoulders of Lockheed Martin's Skunk Works team, led by the legendary Clarence Kelly Johnson. Skunk Works was a secret division within Lockheed Martin, known for developing cutting-edge technology under wraps. Their mission was clear: to design an aircraft that could fly faster, higher, and remain undetected. It was a challenge of epic proportions, but the Skunk Works team was more than up to the task. The design process was shrouded in secrecy. The team worked tirelessly, exploring new frontiers in aviation technology and materials. The SR-71's iconic black titanium skin, chosen for its ability to withstand extreme temperatures, was sourced from the Soviet Union itself, in a twist of delicious irony. The objectives were ambitious. The aircraft was designed to fly at over 3 times the speed of sound and at altitudes above 85,000 feet. It needed to evade radar detection, making it a ghost in the sky. Moreover, it was to be equipped with advanced surveillance technology, providing critical intelligence in real time. The Skunk Works team poured their collective genius into the project, overcoming countless obstacles along the way. The result? An aircraft so advanced it seemed to belong to the future rather than the present. Thus, the SR-71 Blackbird was born, an aircraft ahead of its time. The SR-71 Blackbird was not just fast, it was technologically advanced and innovative. The Blackbird was a marvel of engineering, a combination of unique materials and ingenious design. Let's dive into what made this aircraft so special. A significant part of the Blackbird's speed and stealth capabilities came from its unique construction materials. Primarily built from titanium, a metal known for its strength and lightness, it was sourced from the most unlikely of places, the Soviet Union, during the height of the Cold War. This material allowed the Blackbird to withstand the intense heat generated by its high-speed flight, up to 800 degrees Fahrenheit on its leading edges. The SR-71's design was just as innovative as its materials. Its distinctive shape, characterized by a sharply pointed nose and backward swept wings, wasn't just for aesthetics. This was a practical design choice made to manage the shock waves generated by supersonic flight, effectively reducing drag and enabling the aircraft to maintain its incredible speed. Another key aspect of the Blackbird's design was its engines, the Pratt & Whitney J58S. These were not just ordinary jet engines, they were hybrid turbo ramjets. Below Mach 2, the J58S functioned like regular jet engines, but beyond that, they operated as ramjets, using the speed of the aircraft to compress incoming air for engine combustion. This innovative design allowed the Blackbird to cruise comfortably at speeds over Mach 3. The creation of the SR-71 was not without its challenges. The high temperatures at high-speed flight caused the aircraft to expand several inches, leading to fuel leakage on the ground. The engineers solved this problem by designing a unique sealant that could withstand the extreme conditions. And let's not forget about the Blackbird's advanced surveillance technology. It was equipped with high-resolution cameras capable of photographing broad areas from a height of 80,000 feet, producing images so detailed they could capture a car's license plate. These innovations made the SR-71 Blackbird a legend in aviation history. With its groundbreaking design and technology, the Blackbird truly was, and still is, a testament to human ingenuity and the limitless possibilities of aviation technology. So, how fast could the SR-71 Blackbird fly? Quite simply, the Blackbird didn't just fly, it soared at speeds that boggle the mind. The Lockheed SR-71 Blackbird holds the record for being the fastest air-breathing manned aircraft in the world. This record is no small feat and has remained unbroken since it was set. The Blackbird reached an astounding maximum speed of over Mach 3. That's 3 times the speed of sound. To put that into perspective, it's like traveling from New York to London in less than 2 hours. Now that's what you call fast. This incredible speed was achieved through a unique combination of design and technology. The Blackbird's engines, known as Pratt & Whitney J58S, were not just regular jet engines. They were hybrid jet ramjets. At lower speeds, they functioned as conventional jet engines, but at higher speeds, they acted more like ramjets, sucking in huge amounts of air to provide the necessary thrust. But it wasn't just the technology that made the Blackbird fast. It also had a lot to do with the brave men who piloted this incredible machine. These pilots were not just ordinary aviators. They were part of an elite group, handpicked because of their exceptional skills and courage. Flying the Blackbird was not for the faint-hearted. The cockpit was a place of extreme conditions. The external temperature could reach up to 800 degrees Fahrenheit due to the friction of the airframe with the atmosphere at such high speeds. But despite these challenging conditions, these pilots pushed the limits of what was thought possible in aviation. The SR-71 Blackbird was not just an aircraft. It was a marvel of engineering that pushed boundaries and broke records. It was a testament to human ingenuity and the relentless pursuit of speed. It was a symbol of what we can achieve when we dare to dream and have the courage to pursue those dreams. The SR-71 Blackbird redefined the limits of speed, setting records that still stand today. It serves as a reminder that the sky is not the limit, it's just the beginning. The SR-71 Blackbird was retired, but its legacy lives on. This iconic aircraft, with its sleek silhouette and unparalleled speed, has left an indelible mark on the world of aviation. The Blackbird was a trailblazer, setting records and pushing boundaries in ways that continue to influence modern aviation. The Blackbird's technology was groundbreaking. Its unique titanium frame, designed to withstand the intense heat generated by Mach 3 speeds, set the standard for high-speed aircraft. This heat-resistant technology has been incorporated into the designs of many subsequent aircraft, enabling them to achieve greater speeds and altitudes. Furthermore, the Blackbird's advanced surveillance capabilities revolutionized the field of aerial reconnaissance. Its high-resolution cameras and radar systems could capture detailed images from altitudes of 80,000 feet, providing invaluable intelligence during the Cold War. These surveillance technologies have been refined and adapted for use in today's unmanned aerial vehicles, enhancing our ability to gather information from the skies. In addition to its technological contributions, the Blackbird taught us valuable lessons about the challenges of high-speed, high-altitude flight. It showed us the importance of precision in aircraft design and the necessity of rigorous pilot training. These lessons have informed the development of today's supersonic jets and the training of their pilots. The SR-71 Blackbird was more than just an aircraft. It was a symbol of human ambition, a testament to our ability to innovate and overcome obstacles. Its influence can be seen in the sleek lines of today's fighter jets, in the advanced surveillance capabilities of our drones, and in our ongoing pursuit of speed and altitude records. The SR-71 Blackbird, a testament to human ingenuity, continues to inspire us even today. It reminds us that the sky is not the limit, but just the beginning. As we look to the future of aviation, we carry with us the legacy of the Blackbird, a beacon of innovation and a symbol of our limitless potential.